Okay, in question 22, we are supposed to find 22 part 1, we are supposed to find the size of angle theta that's being marked out in the diagram. Alright, what we can do here is we can make use of the previous topics knowledge. Okay, circle properties, because if we look at the diagram, T is a exterior point from the circle and we have two tangents here. Okay, two straight line. PT is my tangent, TQ is also my tangent. Alright, so what we can recall, tangent is perpendicular to radius. Okay, tangent is perpendicular to radius, and we can actually draw a line across here. It will cut theta into two. Okay, it will cut theta into two, so it will bisect theta into two equal parts, the angle theta. Alright, so what we can do here, since we have 14 and 8 and we have right angle, we can use our trigonometry to calculate. And in this case, it will be this is 8 is opposite and 14 is adjacent to my theta over 2 here. So tangent theta over 2, okay, is 8 over 14. So angle theta over 2 will be inverse tangent 8 over 14. Okay, and if you want to find theta, just multiply 2 across. Okay, and we will get our answer. Alright, so remember, when you press into your calculator inverse tangent, you've got to make sure that your calculator is in radian mode. Alright, it's in radian mode. So how to check if your calculator is in radian mode? There's a small alphabet, okay, on the top row of the display of your calculator. It should read R instead of D. Okay, by default, once you reset your calculator, it is in degree mode and there will be a small d on top. Okay, so to change it, you can make use of the mode function, alright, where you will reach a page where you can choose degree radian. Okay, degree radian dr, and there's another one g, alright, but g is not useful at this point, so you change it to radian. Okay, before you do any of this trigo calculation on your calculator. Alright, so your answer will be 1.03829. Okay, 1.04 radian in 3SF. Alright, so this will give you the size of angle in radian here. Okay, so next part we are supposed to find the shaded area. Okay, so how can we find the shaded area? Alright, we can find the size, okay, the area of this quadrilateral here and subtract by this sector of a circle. Okay, sector of a circle PQO. Alright, so in order to find the area of quadrilateral, okay, it's actually a kite. Alright, so area of POQT is quadrilateral. Alright, we can use 2 times of just now I have drawn the triangle here, triangle. So 14 half times 14 times 8, we will get this one triangle, so we multiply by 2. Okay, the area of 2 triangles, so half times 8 times 14. Okay, and area is 112 cm square. Alright, in the next part, okay, we are supposed to find the area of sector. Okay, this sector OPQ. Alright, so area of sector formula equals to half r squared theta. Okay, we know that r is 8, so we got to find theta in terms of in radians. Alright, theta. Okay, this angle here. So we can make use of circle properties. Alright, to find. Okay, what you can do is angle POQ. Okay, if you work in degrees, it will be 180 subtract by theta. Okay, 180 degrees minus theta, because we have 2 right angles here. So sum of angles inside quadrilateral is 360. So after we take away these 2 right angles, we are left with 180. So 180 minus theta. And in terms of radian, 180 degrees is pi radian. Alright, a bit of a recap. So pi minus theta 1.04. Okay, we should use a more exact value because we are still calculating towards the answer. Okay, so in terms of area of sector, POQ, right, be half times 8 square times pi minus 1.03829. Okay, so okay, maybe we can leave it like this. Okay, so 8 square is 64, 64 divided by 2 is 32 times pi minus 1.03829. Okay, so in our last step, shaded area equals to area of the whole for the lateral 112 minus 32 times pi minus 1.03829. Okay, you should get 44.694338. So round off to 3SF. 44.7 cm square is our shaded area here to 3SF. Okay.